This telescope is 100 times more powerful than the Hubble telescope. The mirror of this telescope consists of 18 hexagonal mirrors with a diameter of 1.32 meters, and in total it makes a 6.5 meters mirror, which is 100 times more powerful than the 2.4 meters mirror of Hubble telescope. The mirror of James Webb Telescope is made of beryllium. The beryllium plates are well polished and covered with gold. But why are mirrors built into hexagons? To send the telescope into space, mirrors need to be retractable to fit inside the rocket cargo space. Thus, the mirror must be made in such a way that it can be retracted, and it can be made in one piece, like the mirror of Graham telescopes. But the base shape for the mirror was hexagonal, because there was no gap between the mirrors. Let's assume that they made mirrors in circle shapes. Then these mirrors couldn't create perfect coverage. But this is not a normal telescope, and it works in the infrared range. This means that the maximum sensitivity of its cameras is set for the infrared region. There are two reasons for this. First, infrared radiation can pass through interstellar dust and not be trapped behind the dust like visible light. Second, the wavelength of light that reaches us from far away, for various reasons, is drawn and approaches red. That's the reason why it's better to make our observations at longer wavelengths. The light that collected by the main mirror of the telescope are sent to its advanced sensors and cameras to be well analyzed. The function of James Webb Telescope's main camera, the NIRCam, is take an image from galaxies and systems. This tool is also equipped with a chronograph. When we look at an intense light source like the sun or a projector, we can't see anything around that source. But when we put our hands in front of the light source, we can see around a little better. The chronograph does exactly the same thing, and when the telescope looks at an intense light source, it covers that part and tries to get more information from around it. This could help direct imaging from exoplanet systems and planets, but it can't tell us anything about the characteristics of those planets. There is an advanced spectrometer on the telescope for this purpose. This tool can detect mass, temperature, and chemical composition of celestial bodies by analyzing the received light from them. Of course, obtaining such information from out-of-reach celestial objects requires years of telescope exposure. This means that the telescope may need to look at a point for 10 years to collect enough light from that object. But this time is too much. So telescope tools are installed for the purpose of a spectroscopy of hundreds of celestial bodies simultaneously. But these tools have to operate at very low temperatures. The lights coming from the sun, earth, and moon to the telescope can increase its temperature, and it can disrupt the telescope operation. For the same reason, in addition to the telescope's internal cooling system, 5 protective shields are embedded at the bottom of the telescope, so other radiation cannot disturb operation of the telescope. The James Webb Telescope is able to capture the light of the first stars and galaxies of the universe, and answer many of our questions, and create new ones for us. Now, we are in a dark room, and we can look outside through a small hole, which is provided by James Webb.